three trig ratios. We're going to use them again today. So we learned that given theta and angle theta, given theta, we can identify the opposite side, the adjacent side, and the hypotenuse. So once again, opposite, oops, I grabbed this and moved it, just a second. Opposite, adjacent, and hypotenuse is across from the 90, right? And if we know that, then we know the three trig ratios. Sine of theta, cosine theta, tangent theta. And our saying goes, oh heck, another hour of agony. Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. We're all okay with those. Okay, so don't take notes during this piece, just watch. It says find sine theta, cosine theta, tangent theta. So looking at our right triangle, are we missing any sides? So we can find all of them quite quickly. So we have sine of theta is equal to opposite over hypotenuse. So from theta, opposite
2 over
hypotenuse. 2 over the square root of 5, and then we need to do what?
The square root of 5. Square root of 5 for top and the bottom.
Very good. We need to rationalize the denominator. So on top we have 2 square roots of
5.
And on bottom we have
The square root of 25.
the square root of 25, which is 5. So that would be, that is sine of theta, right everybody?
Yeah.
Cosine of theta is, oh heck, it's another hour. Adjacent over hypotenuse. So 1 over the square root of 5. And then we'll multiply the bottom and the top by the square root of 5 to rationalize the denominator. So straight across, 1 times the square root of 5 is the square root of 5. On bottom we have the square root of 5 squared, which is 5. And then tangent to theta is of agony, so opposite over adjacent, so 2 over 1, which is 2, right?
Yeah.
Okay, awesome. So we're all good with those. Very good. All right, so now understand something. We were asked to find sine of theta, cosine theta, tangent of theta. But if we were asked to find the measure of angle theta, that's different. So does everybody see the difference? Now I'm asking you not to find sine theta, not to find cosine theta, but to find theta itself. So before we can do that, I need you to all get your calculators out. So pull up your calculators. Go to the mode. Go to mode. Mode.
What the?
Mode. Right here. Scroll down to where it says radians. We need to change our calculators to degrees. Because we're calculating theta, and theta is an angle, and angles are degrees, we need to change our calculator to degrees. So you'll scroll over with your arrows and hit enter. I want it in degree mode. Does everybody know how to switch their calculator? Did you just do it? Okay. Now you'll do second quit. Now we'll want our calculator in degree mode for anytime we're calculating something with an angle, or where we have degrees involved, we need to have our calculator in degree mode. So when you go to the ACT, guys, if you're ever asked to find an angle measurement, or you're using an angle measurement to calculate for a side, you have to change your calculator to degree mode. Now, degree mode, actually, you can leave your calculator in degree mode and it will calculate most other things correctly. So you'll just leave it in degree mode this whole unit. Okay, everybody? Is everybody good with that? Okay. All right. All right, so now we're going to find the measure of angle theta. So pay close attention. Look at our right triangle. Do we know all the sides? No. We don't need to know all the sides, though. We don't need to know all the sides. We're going to use the information we're given, and we're going to pick which trig ratio we're going to use according to the picture. So everybody look with me. From theta, we have the opposite side, right? Does everybody understand that we have the opposite side? And we have the adjacent side. Yes?
Yes.
Okay, so we have the opposite side and adjacent side. Which trig ratio uses opposite and adjacent? So we're choosing in this problem in particular to use tangent of theta. So we have tangent of theta is equal to opposite, which is 2, over adjacent, which is 1. So what we have is tangent of theta is equal to 2, right? Everybody? Now that's not theta, that's tangent of theta, but we can find theta. So guys, think about, we're just solving for theta. Think about if you're solving for a variable, you apply inverses, right? To get the variable alone. So we've got to apply an inverse to get theta alone. So what we're going to do is apply the inverse of tangent, which is literally the inverse of tangent. Tangent inverse. So if you do that to the left, you've got to do that to the right. Tangent tangent inverse. Do you see how I did the exact same thing to both sides of the equation? Yes? Or no? Okay. So then over here on the left, tangent inverse. Now that -1 just means inverse, everybody, okay? So tangent inverse and tangent are cancel out. That's what inverses do. So we're left with theta. So theta is equal to the tangent inverse of 2 on the right. And then from there, you just type it into your calculator. Do you see how I got theta alone? So now you'll type it into your calculator. So pull up your calculator and you type it in like this. So everybody, you'll hit quit, get out of the, make sure you're in degree mode. Okay, so then you'll go like this. Now everybody see the sine, cosine, tangent keys. Now right here is tangent, but we need inverse tangent. So if you notice in little writing above, it's inverse tangent. So you hit second, tangent, and notice how it wrote inverse tangent. So the inverse tangent of 2, that's what we're calculating, and that is theta, right? That's our angle. So you hit enter, and you get 63.4 degrees. 63, so theta is equal to 63.4. So theta is equal to 63.4 degrees. Does that make sense? That is theta. Did we solve for theta? Yes. So that angle right here is, I don't need to put it in, I'm just saying, 63.4 degrees. Does everybody understand? Let's do one more. Okay, another one. It says find theta. Paying close attention. Are you all paying attention? Find theta. So, we'll look at our picture and say, well, what two sides do we have? So from theta, I have the hypotenuse and the adjacent. So which trig ratio do I have to use?
Cosine.
Cosine. So what we have here is we're using cosine of theta is equal to adjacent over the hypotenuse. Then put in everything you know. So we have cosine of theta is equal to the adjacent, which is 3, right? Over the hypotenuse, which is 5. Now theta is not alone. We can make it be alone by applying the inverse. So we're going to take the cosine inverse of both sides of the equation. So then cosine inverse and cosine cancel out. We're left with theta is equal to the cosine inverse of 3 divided by 5. 3/5 is 3 divided by 5. So take your calculator, type it in. Cosine inverse, second cosine of 3 divided by 5. 53.1. Very good. 53.1 degrees. Theta is equal to 53.1 degrees. Any questions on how to do those?
On this, we're going to have to solve all for the next angle too.
And we can do that after that, you just by 180 degrees, right?
Yep.
Yeah. Okay, so do problems 1 and 2. Ready, set, go. And I'm only going to give you a couple seconds and then I'm moving on. Here. All right, so this time we're asked to solve for x. In fact, I'm going to erase it. And I'm going to write, okay, well, you know what? Let's solve for side B. Does everybody understand? Since this is angle B, this right here is side B. Do we all understand that?
Right. Yep.
Yeah or no?
Yep.
Okay. Now, everybody, let's look at what, so also we're given 22 degrees, right? So right here is our theta. So we're going to go off of what we're given here. So from there, what two sides do we have? Opposite and adjacent. Okay, which one is opposite and adjacent? Tangent of theta. So what we have, what we're using is tangent of theta is equal to opposite over adjacent. Now we're going to plug in everything we have. So we have tangent of, do we know theta?
No. Yes.
It's 22 degrees. So tangent of theta, well, theta is 22 degrees. Does everybody see why I plugged in 22 degrees?
Yeah. Yeah.
It's equal to the opposite, which is 15 over the adjacent, which is b. Now look at our equation here. Do we have one unknown?
Yes.
Yes, just one unknown. Now we're going to solve for b piece by piece algebraically. So I want to get b alone piece by piece. First thing I'm going to do is multiply both sides by, because it's in the bottom of a fraction, I want to bring it up, right? You can't just float it up though. So I'm going to multiply both sides by b. Now what happens on the right? b over b Cancels out. So we have B tangent of 22 degrees is equal to 15. Now a lot of people want to from here, they say, well, we just take the tangent inverse. That's not going to help us. If we take the tangent inverse, we're going to have a huge mess. We're going to have a floating 22 degrees, right? It's just going to be a big mess. And you can't just take tangent inverse of a piece. So understand something. You never take the inverse, tangent, inverse cosine, inverse sine, unless you're solving for an angle. Did you all hear that? You will never, ever, ever use the inverse, tangent, sine, cosine, unless you're solving for an angle. Is side B an angle? No. So we're not going to take the inverse. How do we get B alone? Divide both sides by tangent of 22 degrees. Won't that get rid of it?
Yes.
Divide both sides by tangent of 22 degrees. Now look, over here on the left, what's 2 divided by 2? It's 1. So what's tangent to 22 divided by tangent to 22? 1, right? Isn't anything divided by itself 1? Okay, so we have B is equal to 15 over tangent of 22 degrees. And can't we just type it into our calculator? Yes.
Yeah.
Okay, so get your calculator. Now this was not the inverse tangent, it was tangent. So you get your calculator. 15 divided by tangent of 22. So you type it in. 15 divided by tangent of 22. Close your parentheses. Does everybody see that I'm just typing it in? And our side length is 37.1. We'll round to 1 decimal place today. 37.1. Everybody good with that? Are you following me? So B is equal to 37.1. So does everybody see how I found that side? Okay. Any questions on that?
So the side is 37.
Right. Wasn't that what we were finding? Was the side? Yep. So the side, that length, that side B is 37.1. Okay. So now we're going to apply all of our knowledge, all of it, all together. Are we ready? Are you ready for the big whammy schwammy? Are we good? Okay, here we go. Guys, here we go. This is where you need to focus. Solve the triangle, which means find every angle, find every side. Find every angle, find every side. Let's all have a pity party for a second for everybody. All right, that's what we'll do. Okay, so everybody look right here. For this is what we're going to do. First thing, we're going to find all of our angles, okay? So if you follow these steps, it's going to make it easier on you. So the first step is to find all your angles. So we're going to find angle A, right?
Right.
Now it's too hard for me to check your work. I want you to write your answers all together and write it all like this. So we're finding angle A, right?
Right.
Can't we just say, oh, well, we know all 3 angles of a right triangle or of a triangle add up to be 180?
Right.
So 180 minus 90 minus 22, right? 68 degrees. So we know angle A is 68 degrees. Does everybody understand? That's nothing new to us. Is everybody good with that? No questions on how I did that, right? You sure?
Okay. Flat out easy. Come on.
So we found all the angles. Okay, so now your next step is to find all the sides. So I'm going to put in, this is side A, right?
Yep.
This is side C. So now I'm going to set up a trig ratio to be able to solve those sides because we cannot use the Pythagorean theorem, can we?
Yep.
Okay. So I'm going to use, now this is the important part. We can use 68 or 22. Whatever one you want to use, you can use. But you've got to make sure that you're consistent because your trig ratio will be different if you choose a different angle than your neighbor. So do you want to use 22 degrees or 68? Okay, so everybody, I'm circling 22 degrees so I remember that that's the theta I chose. Does that make sense?
Right.
So now let's set up a trig ratio to solve for A. We're obviously going to use 15, right?
Right.
So we're going to be using the opposite and the adjacent. So which trig ratio for this one? Tangent. So I'm finding A. So tangent of theta is equal to opposite over adjacent. Are you all following me?
Right.
Plugging in theta, so we have tangent of 22 degrees is equal to the opposite, which is 15, right? Over A, right?
Right.
Are we all following? So then we'll just solve for A algebraically. So I'm going to multiply both sides by A, but it divides out over here. Then to get A alone, we'll divide what?
Tangent.
Good. Divide both sides by tangent of 22 degrees. So 15 divided by tangent of 22 degrees.
Do you have to keep the degree sign in there?
No, I'm just reminding you that it is a degree. You don't have to. I mean, you don't type it in your calculator, you know? Okay.
Yeah, I feel
So A is equal to 15 over tangent of 22 degrees. Type it in your calculator. You tell me what is it?
37. Wait.
37.1. So 37.1. So side A, now write your sides as little variables. That's what sides are. They write them as little variables.
37.1.
So side A is 37.1. Now, if you go through and choose to use the Pythagorean theorem from here, then that's fine, I guess. But you have to use the full decimal. Do you understand?
Oh yeah, that's easy.
Now, no, it's not actually. And no, it's not. Okay, no, just watch, okay?
I'm gonna do it that way then.
Okay, so it's not quicker. You might think it's easier because you don't want to have to think about trig ratios. Okay, so if you choose from here to use the Pythagorean theorem, I don't care. That's fine with me. But do you understand you cannot say 15 squared plus 37.1 squared? You would have to use the full decimal for 37.12, 7, 8, 9, 10, 12, whatever.
1, 2, 6, 3.
Okay, yeah, but do you get what I'm saying? Okay, so guys, it would be easier. Watch how quick this is. I'm just going to set up a different trig ratio. I'm going to use 22 again. I'm solving for C, right? So I'm going to use opposite over hypotenuse. So which trig ratio am I using now? Sine of theta. So I'm going to now go sine of 22 degrees, right? Is equal to opposite, which is 15 over C. And then we do the same thing. Cross multiply by C. Divide that over here. Divide both sides by sine of 22 degrees.
Wait, don't tell me the answer yet. I'm still doing
Exactly.
Oh, good example. Exactly. Ooh. Okay.
Got it.
All right. So type that in. 15 over sine of 22. 15 divided by sine of 22, and you get 40.
40. Yep.
So we got B, or
Time is here.
side C is
40.
40. Side C is 40. And have we filled in our full triangle?
That's right.
Now I cannot check your answers when they're all over the place. Find a place on your paper and go like this with your answers, or else I'm not going to check them. Okay? Okay. Do you understand what I'm saying?
Wait, so let's find that angle that's missing, and
You think this is bad? You just wait, honey. What?
Honey. Ooh.
we have to find the missing stuff.
Yes. Because, well, yeah, we only have to list, we found the whole triangle, we're only missing, I'm not scared, that was on recording, so. Okay, let's do another one. Here we go, are you ready to do another one?
Of course.
Okay, here we go. So, solve the triangle. Guys, pipe down. First thing we do is find all our angles. What am I going to do? 180 minus 33 minus 90, right?
Yeah.
Angle B. Let's go quicker through this one. What's angle B?
Like 50 something.
No, tell me. Somebody do it. Go.
Wait.
57.
Hold you.
57 degrees. Does everybody understand? I better not have any of you then, when I walk around, say, I didn't get it at all. Ask questions right now. Because that's what your voices sound like to
Hurts
me.
my ear.
So because we have
Okay, let's find side B and side A, right? Everybody. So, which one do you want to use? 33 degrees or 57? Do you understand you get a pick?
Yeah.
Okay, but you have to set up a true trig ratio. So, for side A, I'm going to use opposite and hypotenuse, right?
Yeah.
So, that's sine, right?
Right.
So, sine of 33 is equal to the opposite, which is A,
Over.
over the hypotenuse, which is 45. Do you see what I did? Opposite over hypotenuse. Then solving for A, I'm going to multiply both sides by what? 45. And look, isn't A all by itself? So we're done. Calculate it. 45 sine of 33.
24.5.
24.5. So side A is 24.5. Now I have to use the full decimal if I was going to use the Pythagorean theorem. I'm just going to set up another trig ratio. Watch, this one's way quicker. We're going to use hypotenuse, right? And we're not gonna use that side because we don't want to use the full decimal. And adjacent, so we're using hypotenuse and adjacent. So which one? So cosine of 33 is equal to adjacent, which is b, over hypotenuse, which is, then we cross multiply both sides by 45, and we're done. Type it in. 45 cosine of 33. 37.7. And we've solved for side B. 37.7. Does that make sense, everybody? So I write my answer like that. Angle B is 50. So angle B is 57 degrees. Then side B was 37.7. And then side A was 24.5. So that I can check your answers quickly. Okay? Questions? You're sure? So you're going to be able to do the first problem when I set you loose. Let's hope so, because I've got 2 examples. Okay, do these problems. Ready, set, go. Okay, now guys, this is way cool. Your triangle should make sense. So look, my 22 degrees was my smallest angle, right? It better be across from the smallest side, was it? 68 degrees is my middle angle. Is that across from my middle length side? And 90 degrees is my largest angle. Is that across from my largest side? So your triangles will make sense. Look right here. 33 degrees is my smallest angle. Was that my smallest side? Medium angle, was that my medium length side? Yep. And then 90 was my largest angle, largest side. So you can kind of check your triangles and say, do they make sense? All right, so do these problems as you go check them. Now, what's our first step? Find all the angles. What's our first step? Find all the angles. So I'm doing number 5. So pay very close attention and ask questions. We have this triangle on number 5. What is my first step to solving a right triangle? Find all the angles. So the first thing I'm going to find is angle, oh, I forgot to label it, sorry. It's ABC here. ABC. So first thing I'm going to do is find angle A. I go off to the side and I find angle A. Do you understand? You take 180 degrees because all 3 angles of a triangle add up to be 180. 180 minus 90 minus 64. So angle A is equal to 26 degrees. I'm going to pause there. Does everybody understand how to find all the angles of a right triangle? Then from there, you get to choose. Which angle do you want to use? 26 or 64?
26.
Okay, we're going to just go with 26. So I circle it so I don't forget that's what I'm using. Does everybody understand step 2? Okay, now don't I need to find side A? Look, angle A, side A. Yes?
Yes.
So we're going to be using, since you chose 26, we're going to be using opposite and hypotenuse, right? So opposite and hypotenuse, which trig ratio? Sine. So everybody, sine of theta is equal to opposite over hypotenuse. Does everybody understand why I'm using that?
Yes.
So then I plug in everything I know. Sine of 26 degrees is equal to the opposite, which is A, over the hypotenuse, which is 6. Back there, back group, are you following me? Are you understanding? Arnisha, do you get it? Do you understand it? So then what's my next step? Very good. We need to get A alone. So we're going to multiply both sides of the equation by 6. Now, Matthew, is A alone?
Yeah.
So we're done. Type it into your calculator. 6 sine of 26. 6 sine of 26.
2.6.
So you get 2.6 is equal to 8. So we solve for side A. So side A is 2.6. So I put that as part of my answer. 2.6. A is 2.6. Are we all okay with that? Now this is where a lot of people are like, well, now I don't know what to do. But you knew what to do before, so you do know what to do. Aren't we finding side B now?
Yes.
We're still using 26, but now we're using the adjacent and the, don't use the 2.6 or you have to use the full decimal. Use what you were given. So adjacent and the hypotenuse, which is cosine. So cosine of theta is equal to adjacent over hypotenuse. Does everybody understand why I'm using adjacent and hypotenuse? You get it, measure O. Okay. So then I plug in everything I know. So I know theta is 26. So cosine of 26 is equal to the adjacent side, which is B, over the hypotenuse, which is 6. And then from there, we're just algebraically solving for B. So I'm going to multiply both sides by 6. And then B is completely alone, so we're done. 6 cosine of 26. If you type it into your calculator, 5.4. So we have 5.4 is equal to B. So then in my answer, I say B is 5.4. I could write it up here if I wanted. Then I circle my answers. My first step was find the angle, then find a missing side length, choose what theta you want, set up a trig ratio, and algebraically solve. So I better see some of you kick it in gear.